Okay, so did you guys all get my email about Gradescope? Did you all get the email from Gradescope? And you set up your password on it so that you can submit the classwork today. What this does for you is it allows you to keep the classwork yourself, take it home with you, and use it as studying, and it allows us to be able to grade it at the same time. It makes grading a little bit easier in that we have a set of comments and we can just click a button and it'll put the comments next to the question. So if you forgot to do something, we can make a comment. But if 20 of you forgot to do the same thing, we don't have to retype that comment every time or rewrite it every time. It just gets put on the papers. So hopefully the feedback will be a little bit better for you guys. It'll be easier for the graders. And you can also keep your papers yourself. Okay, so what we're doing here for our series, we want to be able to find a way to check and see if these series converge or diverge relatively easily. One of the easiest tests is our nth term test. Our nth term test only tells you divergence. It does not tell you convergence. But if you look at what's inside your series and you say, oh, that is not going to have a limit of 0, then your first thing you should do is apply your nth term test. That's the easiest test to apply. So we always check for that one first. And then the second thing you do is you just go through and check and see if it's one of our basic type of series. Is it a geometric series? A geometric series is a number to a power n. If it's a geometric series, we know immediately whether it converges or diverges based off of what that number is. Is it a p series? That's 1 over n to a power p. Here again, we can tell immediately if that converges or diverges based on what p is. And then the telescoping series, this one would be where you use partial fractions for integration. I will always give it to you on the test already as a difference of 2 fractions. You won't have to do the partial fraction decomposition on the test. On WebAssign, it doesn't always keep them separated for you, so you may have to do a partial fraction decomposition on WebAssign. And then the last one, basic type that we have is an alternating series, and you can check and see if your series has -1 to a power in it, then it's an alternating series. The last two that you're going to look at, well, the last three, the ratio or the root test. Remember, the root test never works for p-series, which is why we check to identify p-series first. And the ratio test sometimes does not give you much help in similar situations. So identify the basic series first. If you know it's one of those, use that. Then you can try the ratio or the root test because that's our next easiest test. It's just taking a limit. If that fails, try a limit comparison or a direct comparison test. Those ones are a little bit harder usually because you have to figure out what to compare it to. And then the last one is an integral test. The integral test is the longest test, the hardest test, so you probably don't want to do this one unless you absolutely have to. There will be cases where you need to use the integral test. No other test will work. So let's look at a bunch of examples. This says, what test should we use to determine the absolute convergence, conditional convergence, or divergence of each series? Look at the first one. Look at your guidelines right there. When you see the same powers of n in both the numerator and the denominator, you should know something about the limit. You know the limit's not going to be 0. What do we think that limit's going to be for the part inside the summation? 1/3. So that tells you immediately you should try an nth term test for this one. That limit is going to be non-zero. Nth term test says if the limit of what's inside is non-zero, you're going to be adding that non-zero term an infinite number of times. You have to have infinity for your answer. It does not converge, it diverges. Okay, look at number 2. What kind of series question? Oh, I always forget the lights here. I'm at the front and it looks just fine in that direction. Look at number 2. What should we do here? Geometric. How about number 3? Nth term test doesn't work because you have infinity times 0. Infinity times 0 is one of our undefined things. We really don't have to go down that route. It actually does have a 0 limit if you do L'Hopital's rule enough times. Is it a geometric series? No. Is it a P-series? No. I forget what the next one was on the list. Is it telescoping? Is it the difference of 2 fractions? No. Is it an alternating series? No. No. The negative is an exponent. It's not down to front. It's not minus 1 to the power. So it's not any one of those basic ones. I will tell you right now, the ratio test is not going to work on this one. You get a 6 over 1. The root test doesn't work because you have the n down in front. For the root test to work, it has to be everything to the power of n. So that doesn't work. This one's an integral test. Yeah. Integral test. How about number 4? No, it's not the multiple of 2 things in the denominator. I can't factor it, so it's not telescoping. It is 1 fraction. This is actually a direct element comparison. In fact, this one has to be a limit comparison to your series of 1 over n. You can't do a direct comparison to it because it's smaller than 1 over n, but your series of 1 over n is our harmonic series, and that one diverges. So smaller than a divergent doesn't tell us anything. So this one is actually a limit comparison. Now, how did I know that? What was my cue? Look at that 3n plus 1. If you take all the numbers away and just leave the variable n, it looks like 1 over n. When you just have constants times n or constants plus n, that is going to be your limit comparison or direct comparison. Whenever it looks very similar to a 1 over n series. Or 1 over n squared, that type of thing. If it's a constant times a p-series type of idea, then you're doing a limit comparison or a direct comparison for that. We're going to go through and do all of these tests in just a minute. We're going to solve every single last one of these problems today. Okay, look at number 5. Alternating. How did you know? -1 to a power. Now notice, if I want to know absolute convergence, I brought that -1 to a power, you have 3 over 4n plus 1. How would you test that if you didn't have the -1 to a power? Limit comparison to 1 over n. So this one is going to be an alternating series test. And limit comparison for the absolute convergence. Combine both of these together and we're going to get conditional convergence. Tell me about number 6. Remember something about ratio tests. I told you ratio tests are very good when you have factorials. This one has a factorial. What should your gut reaction be? Ratio tests. If you have that factorial, the only way to solve it is a ratio test. And then, number 7. It's a root test. Why is it a root test? Everything is to the power n. That's the only time we are ever going to use a root test. Those are an example, one example each for all of the tests that we have. Let's do some, run through all of these examples. Do you guys have them written down, those of you writing it down? Question? You could do a root test with that one, but it's a very particular series of geometric series. And so you save your software just by noting that pi over 6 is smaller than 1. So you want to convert it. You can do a root test. You'll get the same answer. Okay, let's run through some examples here. Determine the absolute convergence, conditional convergence, or divergence of each series. State the test used. So for number 1 here, I have the sum n equals 1 to infinity of n plus 1 over 3n plus 1. And we said this one was the nth term test. How do we do the nth term test? Take the limit of everything inside the summation. So we're looking at the limit of n plus 1 over 3n plus 1. How do I take this limit?